Hello, my name is Mark Guest. I'm the Product Manager for Power Distribution in the UK. Today's presentation I shall discuss Rittle's Switchgear Configurator. This configurator is web-based and will give you the advantage of generating drawings, bill of materials and switchgear that you can build very efficiently, and also will comply to the latest IEC 61439 switchgear standards. But a brief introduction to the actual configurator will be Rittle's Re4 Power Form 4 switchgear, which I'll discuss that very shortly. From the configurator, I shall show you how to generate the drawings and the switchgear design. The Re4 Power is the brand name of Rittle, and it is a Form 4 modular design switchgear. The switchgear is based on VX25, Rittle's platform for enclosures, so a lot of the accessories are common and interchangeable between Re4 Power switchgear systems and VX25 enclosures. One big advantage of the Re4 Power is it has a welded frame. This gives you the strength and performance and meet a lot of specifications where customers want solid welded frames. The actual range of the switchgear goes from around about 400 amps up to 6,300 amps and 100 kA for 1 second. So it is high performance quality switchgear. So the switchgear configurator is online. It can be found on the website, which I'll come to very shortly. So that gives us advantage of the information being up to date, accurate, and can be changed very quickly. So that's a big advantage. The layout drawings is fundamental to any switchgear design. So the configurator will generate PDF drawings that you can use to build and design your switchgear. Also, the 3D models is very useful to give you a sense that you're building the switchgear correctly throughout the design. And later on in the year, in Q4, the configurator will jump into ePlan automatically. That will enable you to use Pro Panel to design the switchgear to the next level, which include the cutouts of the doors, mounting plates, and installing the switchgear, for example. Before you can use a configurator, the configurator needs some basic information for switchgear design. So engineers know from the specification they need to be clear what they're designing. So the basic information that you will actually need, or we need to configure the software. So the key one is schematic drawing, as you can see there. If you do have a schematic drawing, that is great. If not, there's some basic information that we do need to configure the system. Apart from the schematic drawing that you've just seen, other information that the software will need is the current rating of the main bus bars. Of the 3-pole, 4-pole, we do up to 6,300 amps down to 400 amps. So that is key information the configurator will need to start the process. Also, the actual size of the compartments. This can be determined by the current rating of the circuit breaker, the compartment size if it's a motor control centre for the variable speed drive or transformers, etc. Size restriction is also an important thing. The configurator will build the switchgear and the compartments as you input it on the software. But we need to know before you start the process, size of the panel, so there's no clash with the panel being designed too long to fit in the actual switch room. The foam rating of the Re4 Power is either IP2X or IP54. So again, the software has prompts that will ask for these questions on the fault rating, the current rating, the IP rating, etc. before you actually move on to the configuration stage. So this is a worked example just to show you how the configurator does work online. The basic information you can see there. Because we're designed to the latest standards, we need to know the switchgear manufacturer, Siemens, ABB or Schneider. So for this exercise we're using Siemens. As you can see from the picture there, we have a test lab in Germany, and we use independent test stations where we do heat rise tests for the circuit breakers. And the configurator is intelligent enough to calculate which circuit breaker and the maximum current you can get from the ACB. Also, we need to know the design current. That is a total load. So in this case, it is 1200 amps. The switchgear bus bars could be rated at 1600 amps or even higher. But the load current INC is the 1200 amps, and that's critical for the configurator. The foam rating is a segregation of bus bars from the terminals, from the compartments. The configurator again needs to know that it can do foam 2A up to foam 4B, so it has a full range of options. And the key one is the number of outgoing ways. For this example, we've got 10 125 amp MCCBs and 4 400 amp MCCBs. There again, they are Siemens. So what I'm not showing you today, we have a technical manual where we can work out the compartment sizes for each circuit breaker rating, be it 125 amps or 400 amps. And those compartment sizes are 300 millimeters for the 400 amp MCCB and 200 millimeters high for the 125 amps. And also, end of the switchgear, there's a control section which is 800 millimeters wide, will contain the PLCs and the automation controls. So now we've got the worked example details or specification. I shall now show you how to get onto the configurator. To access the Switchgear configuration software, you need to go to this web page. On there you'll see a list of items down the left hand side. If you click on configuration, it will bring you to a number of other online configurators we have in the Rittel portfolio. For this exercise today, we need a low voltage switchgear section. So if we press configure now, it will jump to the switchgear configurator or power engineering page. Being online, as I said previously, it's very quick, interactive as well. It'll give you options to change titles or drop down box, which makes life a little bit easier. So the title will put worked example. It is 4,000 amps up to, so our rating is 1200 amps or so. That's okay. IP rating there will go for IP 54. So I said previously, this configurator to work, we need some information, the dimensions and specification of the customer, etc. But also we need to reference with our manual on the compartment sizes for the ACB and MCCB circuit breakers. So with that in mind, we'll select this rating there as 1600 amps for the bus bars. The load current is 1200 amps, which is the design current. But we'll fit in a figure of 1600 amps, a little bit of tolerance there. We don't want any forced ventilation, and the current rating, the maximum we can achieve is 1530 amp with this particular layout. So that's what I've selected, which is above the 1200 amps loading. It is a 4-pole system, and here we can select the basic layout of the panel. So 2 meters high, 600 deep. We have an option for 800 deep. We'll go with 600, and a plinth at the bottom will have a 100 millimeter high plinth. So that is the basic information. For the most advanced system, it will drill down into the first page of selection. So we've got the title, form separation. This is the segregation of the bus bars from the components and the terminals. Rating of the bus bars, we're going to say, we said 1600 amps, no forced ventilation, 4 poles. Bus bars in the roof are 230 by 10s, which is good for 50k for 1 second. That's the ICW rating, and it's confirming the size. So happy with that, we'll go to the next page. Here we start building the panel up from the specification, the works example. So these are the different options you can select for the configurator. ACB section, bus coupler. The modular section, the outgoing section, is for the MCCB's outgoing sections. This could be a motor control center. It can be 1 enclosure up to 10 enclosures, and a cableway, and an empty enclosure, which we'll need later. So on there, we'll click the ACB, and we want 1 of. Some installations could have 2, 3, or a bus coupler, or a generator incomer, but our works example, we just have 1 incomer. So it is a 4-pole circuit breaker. Default, so a minimum of a 600 wide. The maximum of that particular arrangement is 1400 amps, and we have 1 mounting plate which fits above the ACB. When we click add, it selects the circuit breaker section. From there, you can probably see the 3D drawing there, which is quite useful. So now look at the detailed specification of the circuit breaker. So we'll give it a name. We'll call it incoming
Number 1, it's in the roof, form 4A. Now this is a very important part of the configurator. We need to know which ACB manufacturer you want. It won't affect the price. It is regarding the testing. All ACBs have different ratings. So if we click Siemens, sounds a little bit too eager there. Just scroll down again. Sorry. We will click Siemens, and there it will give you other options you can particularly select. So underneath the air circuit breaker, we're going for incoming busbar arrangement. That allows incoming cables to be connected to the ACB. That does make life a lot easier when you're connecting large incoming cables, for example. So that is the ACB section. Now we need the outgoing section. So click the modular section. It defaults to form 4A. It's 600 wide. The vertical bus bars are behind the mounting plates, and the rating we require is 800 amps. So we're splitting the load approximately 50-50. So I'll leave that a compartment with 3 doors just to show you how easy it is to change. So now we've added the outgoing section. We click that, we go into that section there, so we can call this feeder section solar, for example. Roof section form 4, partial doors, behind the mounting plates, yep. So we're clicking the module configuration. This looks inside the compartment. As you can see there, it's got the wrong number of doors, or you need to change the doors. So clicking that item there allows you to change that size to 200. So I mentioned previously about referencing our manuals, our technical guides. On there, it will show you that a 125 amp circuit breaker fits in a 200mm high compartment. A 400 amp circuit breaker will require a 300mm high compartment as a minimum. And this project has 10 125 amps, 4 400s. So split it 50-50. So in this enclosure there, it will need 5 200mm high enclosures. So that is 1. So we change that 600 door to a 200, and it gives you more options as you go further down this selection. That could be 1,000 door. We change that to 200, 800, 200. That leaves you 600. So we want 2 300i compartments. So click into the 600. We can change that to 300. Once that looks right, the 3D image will give you that. That's a good little reference guide. So that seems okay for feeder section number 1. So we go back. We need to select the cableway for the outgoing cables. So here, the bus bars need to go through the roof at the top. 400 wide. We click Add. That gives you the cableway. Click into that. We can call that cableway. Bus bar through the roof, yes. Form separation 1. You see from the little 3D drawing there, there's no compartment for the bus bars in the roof, so that has to be changed to form 42B. That means the bus bars are segregated from the rest of the compartment. So the bus bars will be in there, and that is your cable with the cables to drop out through the bottom. So now we need another outgoing section, form 4A again. We want 800 amp behind the mounting plates. Gives you that, which looks good. We click into the module, we'll call that feeder VSDs. Roof plate, yeah, that all looks good. Bus bar, yeah. So now again, we're going to the configuration again, and just to prove again how easy it is to do, we click on each compartment to generate the right number of doors. So while we're doing this, behind the scenes, the software is accumulating all the information for the bill of materials and the drawings. But being online, it's very fast acting, and you can change this at any time, change the door sizes, the widths. So you don't have to go back to the beginning. You can physically go back one page, and that is a big improvement over our previous software system. So now I've changed this around slightly. We have 1, 2, 3, 4, 5 200 high compartments for the circuit breakers, and 2 400 amp circuit breakers behind the 300mm high compartments. So that looks good. We go back with our finished system. Looking through the worked example, we need an 800 wide control section, so we click that. That's 800. We can also go for 400 up to 1200. So for this example, we're going with a 800 wide. Click add. Your panel's done. These little icons there represent splits in the bus bar. So some applications you have to split the enclosure by enclosure, and that puts a break or fish plate in between each enclosure. But it's a lot more efficient, quicker to build. If you click on those, should say, that removes the connection. That would be one solid piece of copper bus bar. So that looks good. We have the panel there as we've designed. This page there, we have 3 options. We can request an offer. If we hit that icon there, which is highlighted, that will send the files, the design, to a customer service department in Hellaby, Rotherham, where we can produce a formal quotation, and the documentation, and price the job as well. The web shop will become live in the next probably couple of months before the end of the year, and that will drop the bill of materials into your web shop account. This will generate the pricing, availability as well. So that's a real big efficiency step. Designing software where you can design it yourself, price it, and get availability all online. The last one there is downloading the information. So there's a lot of information there to download. For this particular example, I'll just look at the PDF drawings. So if we click there and download, there you go. It comes in a zip file. We open that and we see the project. So I've only selected drawings. So the zip file, because I think it's up to 8 different files. But for this presentation today, I'll just look at the drawings. So we click on the drawings. Drawing 1 is in external. That gives you the front view, looking at the panel from the front. There it confirms the circuit breaker and all the doors, compartments, and the cableway and the control section. So the next drawing will be the internal one. This shows the bus bar. So the incoming section, we have the horizontal connections for the incoming cables. On there, you can fit a good number of terminals for lugs for connecting the incoming cables. The A circuit breaker is a Siemens 3WL. Current rating is 1600 amps. That's the rating of the breaker. Don't forget it's been derated. And this is a fixed breaker, or it can be withdrawable. I've clicked on fixed there. The bus bars are in the roof. These are dropper connections, 4-pole, behind the mounting plates. And on the right-hand side, we have the control section. So that is the software and how it particularly works. So there's a lot of information we haven't shown you today, what sits in the configurator. So the drawings here can be DWG. We can do assembly plans, the connection sets, and also design verification documentation. So where your customer wants IC 61439 documentation, that can be done quite easily by just downloading all that documentation. You cover that in your design files. So that is the configurator, and that's the worked example which I showed you earlier.
So that finishes the presentation. I hope you find that is useful on the Switchgear Configurator. Just to summarise, it's web-based, it's accurate, and it will generate the key information you need to build switchgear. That is a generation of bill of materials, drawings, build plans and design certification, which you find very useful. If you have any further questions, please ask them now. I'll be glad to answer them. Alternatively, drop us a line, and this presentation will be recorded and available online very shortly. Thank you for your time. Right, just looking at the web chat, we have one or two questions which I really appreciate. One of the questions is, what happens if you change the ACB manufacturer after you finish the configuration? Well, that is an important question. You would have to reconfigure the ACB section again. If you design it around Siemens circuit breaker, the software will generate the connections for the Siemens breaker. If you use an ABB circuit breaker, physically the same dimensions, but the rear connections are slightly different, so they wouldn't fit. So you'd have to make sure you do select the right connection drawings for the right air circuit breaker. A few more questions. Another question is, what available assistance is there from Rittle on using the configurator? Well, being web-based, it is fairly easy to use, but we can do some worked examples remotely over Teams or Zoom, or we can visit your premises and go through the configurator. If you've got any live projects, we'll be more than willing to help you do this. It's quite easy to do. Another question is what applications do we use reefer power? Well, being built and designed around the VX25 enclosure system, we have welded frames for strength. So we do find petrochemical people, aggregates, heavy industry will specify welder frames, and being modular, we have both advantages there, being modular, flexible and strength of the welded frames. So thank you for those questions. If you do have any more, please send them through on web chat and I'll be only too pleased to answer the questions. Thank you.